Hi, so now we will try out another problem. The problem is given a number. We want to check if it is a prime number or not. So let us quickly recap what is a prime number. So a prime number is a number that has only two divisors, 1 and the number itself. Okay. So if you're given a n and it has only two divisors, 1 and the number itself, then it is a prime number. Few examples of prime numbers. For example, 7. So only 1 and 7 divide 7. The number 11, only 1 and 11 divide the number 11. Or talk about a number like 13. Only 1 and 13 divide this number. 2, only 1 and 2 divide 2. So all of them numbers are prime numbers. So what is a non-prime number? So a non-prime number will have at least one divisor in the range 2 to n minus 1. Okay, at least one divisor in the range 2 to n minus 1. So why 2 to n minus 1? Because we have seen that 1 and n divide all the numbers. They divide prime numbers, they also divide non-prime numbers. But if you have at least one divisor in this range starting from 2 up to n minus 1, okay, so if you find at least one divisor here, then you can say that this number is a non-prime number. Okay, this number is a non-prime number. For example, the number 9, so it has a divisor in the range 2 to 8 and the divisor is 3. So 3 divides 9, so you can say 9 modulus 3, this is 0, hence 9 is a non-prime number. Talk about a number 14, so 2 divides 14, hence this is not prime. Okay, 7 also divides 14, but we need to find only at least one divisor. Okay, one divisor is sufficient to prove the number is not prime. Now given a number, we need to check if it is prime or not. So can we come up with a very simple logic to prove a number is prime or not? Yes, the logic would be that we can try to find out divisor in the range 2 to n minus 1. Okay, find out a divisor in the range 2 to n minus 1. If the divisor is found, if you are able to get a divisor, then yes, the number is not prime. Okay, and if the divisor is not found, then you can say the number is prime. Okay, this is how simple it is to prove a number is prime or not. Now what you can do is you can take a pause and try to think of a flowchart to prove a number is prime or not. Okay, so let us try. The first step, as we discussed, would be a start. Then we will try to read the value of the number that we want to prove as prime or not. So we'll read the value of n. The next step would be what? We need to find a divisor in the range 2 to n minus 1. Okay, that means we will need a loop in this range 2 to n minus 1. So let us say I'm currently at the number I. I will initialize my I as 2. I will say okay, I is 2. And now what I will do, I will iterate till this I is less than equal to n minus 1. This is my stopping point of I. I will check if I is less than equal to n minus 1. So this will go inside a diamond, a rhombus, because it's a condition. If it is less than equal to n minus 1, okay, if the case is yes or if the case is no, okay, we'll see what will happen in each of these cases. So if I is less than equal to n minus 1, then what we will do, we will try to divide n with I and find out the remainder. We will check, okay, if n is divisible by I or not. We'll again put another condition, another if condition. So if n modulus I, if this is equal to 0, now again two things can happen. The answer can be no or the answer can be yes. Okay, now if the answer is yes, what we can do, we can simply say that this number is a prime number. Okay, this number is not a prime number, because for example, talk about a number 9 and you reach 3. So 9 modulus 3 is 0, and hence you can say that this number is not prime. So you can print that this is a not prime number, and you're done. You're done at this point. Okay, so what you can do, you can straight go to exit. You can straightly exit the program from this particular point. But what if it is no? Okay, if it is no, then what you're going to do? So you are going to say that it might be possible that n is not divisible by 2. It might be divisible by 3. So you are going to take I to the next place. So you are going to say, okay, let us increment I as I plus 1. And now what we are going to do? We are again going to connect back here. Okay, so again we are going to connect back here. So again we will go to the next I. We will check if that I is less than equal to n minus 1. If it is yes, if it is divisible, print not prime. Otherwise we increment I and we again do the same thing again. Okay, now finally if you come out of this direction, okay, so in what case you will come out of this no direction? Okay, so can you think in what scenario you will come out of here? The only scenario in which you will come out of from this block is via this arrow, is when you do not exit the loop through inside this direction. Okay, that means we could not find a divisor in the range 2 to n minus 1 that could divide n, and hence from here you can say, okay, if I has reached this value, you can simply say print prime, and then you can simply do exit. Okay, or you can connect to the same exit here, not an issue. Now let us try to dry run this flowchart for value of n equal to 7. Okay, let's see what happens for n equal to 7. So I is 2, 2 is less than equal to 6. So 2 is less than equal to 6. Is 7 divisible by 2? The answer is no. So you increment I, so the I becomes 3. Okay, so the I becomes 3. 3 is less than equal to 6. Is 7 divisible by 3? The answer is no. So you again come here, I equal to I plus 1. You again go back here, okay, via this route. So I is now 4, less than equal to 6. 7 is not divisible by 4. It becomes 5. 5 is less than equal to 6. 7 is not divisible by 5. Again no. You come here and it becomes 6. 6 is less than equal to 6. 7 is not divisible by 6. The answer is no. And the value of I now becomes 7. So when you now come here, okay, so I is 7, which is not less than equal to n minus 1. So hence you come out of this branch and you print that it is a prime number. Hence we say, okay, the number 7 is a prime number. Okay, and then we exit. So if it would have been some other number like 9, so you would have done, okay, 2 is less than equal to 8, but 9 is not divisible by 2. Make it 3. 3 is less than equal to 8, and 9 mod 3 is 0. So you come here, then you hit a yes, you print it is not prime, and then you exit. So in case of 9, you will print that this number is not prime. Okay, so I hope this flowchart is now clear to you and you have understood how we have implemented a loop. Okay, so what part forms a loop? So this box is the starting point of the loop. Okay, this is just a condition inside a loop. This is just a condition inside a loop. Okay, so this part is the starting point of the loop, which has the stopping criteria. Here we have the update condition, and this part is the work done. Okay, so that's all for this video. I hope you have understood the concept. Thank you.